So there are two ways in which face image is acquired. The traditional method is two-dimensional face imaging, which you use a CCD camera and acquire a two-dimensional image. But people said, well, what happens if I take a three-dimensional image of the face or capture three-dimensional information? After all, face is a three-dimensional object. It has some structure in terms of geometry. You know, certain parts of the face, nose protrudes, and there's a hollow region around the eyes. Why don't we capture the depth profile of the face as well? Because the two-dimensional image simply captures the intensity variation of the face. So there are many ways in which you can actually get the depth information. The simplest method, which I'm sure some of you know, is to use the stereo system, that it has two cameras. So you can get the left image, the right image, and then you do the correspondence between the left image and the right image, and you get a depth image. The problem with the stereo is that there are many regions in the face which are smooth, which don't have any feature points. So if you don't have any feature correspondences, then you don't get any depth information. So you get a very sparse depth map, which is not sufficient for getting the face recognition capability. So there have been some commercial systems which actually do what is called a striped light. In this particular case, a laser beam, which is eye safe, is a sheet of laser light, goes across the face, scans the face, and now you get a dense depth map of the face. The problem is that these systems are still expensive, and so they're not very viable to be used. Although it will be nice if we can have such a system for enrollment purposes. So you have a 3D model of the person in the database, and then at the recognition time, you have a 2D image, and then it becomes easier to match a 2D image to the 3D model. But this means that the person you are trying to recognize is cooperative subject who is willing to come and get his 3D model scanned. So in most situations, that's not possible. So typically what happens, the way this system works is that, when you use a system like the laser scanner to get a depth map, you only get what is called the 2.5D image. That is, if you're standing in front of a scanner like this, you will only get a frontal depth map. If you want to get the full coverage of the face, then you have to capture multiple snapshots using the depth scanner. And this is what this image is showing. And my PhD student, he has 5 different scans of 2.5D using the scanner, and then you can mesh them or stitch them together to get a full 3D model of the face. And it is this 3D model now you can store in the database, so that now when you have just a two-dimensional image from a CCD camera, it becomes easier to have a pose invariant or lighting invariant face recognition system. So the most common scenario for designing a face recognition system is to match two-dimensional image to two-dimensional image. That is, what you have in the database is a two-dimensional image, like the driver license scenario. And what you want to match, or a test image or a query image, is also two-dimensional. And it turns out that's the most difficult problem right now. So people have been looking at, well, can we do a better job if we have three-dimensional model and three-dimensional model? Of course, but that becomes a relatively simple problem with not so many applications, because there are not that many 3D models available, and the systems are still quite expensive. So then people say, well, what happens is if we have 3D to 2D matching? That is, we have 3D model, and then we have a 2D image. Now, as I said, that's again limiting because the people may not be cooperative, so you don't have a 3D model. So the next thing is, can we build a 3D model from a video? That is, we have multiple frames of the same person, and can we build a 3D model using what is called a structure from motion? And I will briefly mention that. So what is the state of the art in face recognition performance? Well, there are not that many vendors available for face recognition. Maybe maybe 6 to 10 major vendors for face recognition. And the National Institute of Standards and Technology, NIST, every few years conducts a public evaluation of all face recognition engines, and anybody can participate in it. So the last one was done in 2006. FRBT, face recognition vendor test. They also call it face recognition grand challenge. And the last one they did before 2006 was in 2002. And they said, well, our goal is to improve the performance by an order of magnitude. That is, reduce the error by an order of magnitude. And you know, the government is investing money, at least in the United States, to improve the face recognition technology. Now, it turned out that the FRBT 2006 did meet some benchmark. The numbers are false accept rate of 0.1%. At that false accept rate, the genuine accept rate was about 98% for the best performing algorithm. That is, if you're willing to tolerate 1 in 1,000 wrong matches, then you will successfully recognize about 98% of the time the correct individuals. Okay? So that's not too bad, but the problem is that this was done, even though it was done on a large database, it was all collected in the laboratory setting. So this database mostly was collected at University of Notre Dame, and there were 3 types of database collected. Still images with controlled lighting, that is, you know, where inside a room where the lights didn't change very much. Still images with uncontrolled lighting, and 3-dimensional images. So as you can imagine, when you have an uncontrolled lighting, the performance drops significantly compared to the controlled lighting. But my experience, and most people will vouch for that, is that when you have real operational data, the situation is quite different than when you have control data. But the nice thing is that this database is available for researchers to use, and this has helped in improving the performance of not only face recognition but also fingerprint and iris recognition. Because until 5 years ago or 10 years ago, people only worked with their own proprietary database which they collected themselves. And you can always collect as nice data as you want and report a very high performance. But now that we have some public domain database on which some benchmark studies have been done, you can evaluate your own algorithm and see how far away you are from the best algorithm. So this is just a table summarizing, starting from 1993. So basically, that's the PCA algorithm for face recognition by Turk and Fentlin, which was proposed by somebody else, by Kirby in 1987 paper, but then Turk and Fentlin got more credit for it. And this is the performance, genuine accept rate at false reject rate at false accept rate of 0.1%, and how the false reject rate has been dropping at a fixed false accept rate. So there has been performance improvement, but for large scale, uncontrolled face acquisition, the performance is still not satisfactory. So one of the improvements in the face recognition technology has been obtained by the use of generic face models. Now, I mentioned about the use of the 3D sensing, laser scanner as an example, or structured light. That generates a user-specific model. So I can sit in front of the structured light scanner or laser scanner and build my 3D face model. But that model is user-specific. What has helped improve the technology is the generic face model, both in terms of 2-dimensional and 3-dimensional. So Coots proposed something called the active appearance model. And the idea was to come up with a generic 2-dimensional face, so that given an image, I can extract the facial feature points from